Hey guys, this is Patrick from SunTech Solar doing a live feed on Facebook. And today what we're going to talk about is spring battery maintenance. As you can see, the sun's out, the snow's melting, and it's time to think about boating. And the first thing we need to think about boating is battery condition. So first of all, I'm going to talk about some batteries and what I have here on the table. So we have a wide variety of batteries we can have on our boats, going from 6-volt batteries to heavy duty use to average 12-volt starting batteries, and then we have here some deep cycle 12-volt batteries as well. So first of all, before I get right into it, we're going to talk about battery safety. So battery safety, what I mean about that is when you're testing batteries, servicing batteries, we need to understand how dangerous they can be. So one thing I'm going to talk about is once I open up these caps and do some battery testing in a couple minutes, I'm going to be wearing the safety glasses, nitrile or latex gloves so you don't get that sulfuric acid on your hands, and also some baking soda. Common baking soda, what it does, if you do happen to take the caps off and spill some sulfuric acid on either on this table here or on your battery tray, you can sprinkle some baking soda here. It'll help neutralize the battery acid, so it's an easier cleanup. So come springtime, we're always wondering how our battery condition is. Have our batteries lasted this over the harsh winter time? Have they froze? So first thing we need to do is talk about visual inspection. So as you either go down in your hull or wherever your batteries were maintained in the winter time, we want to take a quick look at the battery casing, make sure that the sides haven't bulged out on the fronts here and the side here, and we see if we can move it, make sure we don't have any cracks. That's a common indication of the battery possibly could have frozen over the winter time. So once we've determined that the battery is safe to test, we're going to go ahead and take these caps off, and then we'll talk about what we're doing. So I'm going to put on my safety glasses, latex gloves, and the tools I'll be using to take this cap off are just a simple straight screwdriver. And now you need to be careful because some automotive batteries like this group here, okay, when they build the batteries, they have little caps underneath the sticker, and it's not serviceable. So if you do need to check the battery condition, checking electrolyte level and because these caps don't come off. So if you gently pry on this cap, we'll pop the cap, just like that. So now a 12-volt battery will have 6 cells. And when you're checking for electrolyte, this is just a common specific gravity tester here, okay, that can be bought at your anywhere automotive store, Canadian Tire store, anything. So here, as you can see here, the specific gravity. So this measures water in the specific gravity. So if this battery acid is weak, it's almost like water, so it'll be equivalent to 1.1 or 1 to 1. So it's measuring specific gravity. So as you take your sample here, this black needle is going to go all the way up from recharge, fair to good to the top level here. And that will determine the cell condition of the battery. And squeeze the, and as you suck in the electrolyte up here, this line here, okay? Now as you can see, this is a well-charged battery because it's showing the 00. So what does that mean, 1.300? 1.300 means 1.30 volts. Okay, so when you times that by 6, 1.3 times 6 will give you a proper charging voltage of almost 13 volts. So now you go ahead and watch this. The battery acid doesn't spill. I will check the next cell, and so on. Cell, and then make sure that your battery's in good condition. As you see again here, it's fully charged and good to go. This battery, so 6 cells. Now what you're trying to do is you're trying to see to make sure that all these batteries cells are within this range here. If you see, take cell number 5 for instance. If you do check cell number 5, and you see the battery voltage of that cell is 1.15 or something going on in this cell, and the battery condition is not the best, and that may be time to think about a new battery. Okay, so I'm going to go ahead and close these caps off. Okay, so now we've gone ahead and tested this battery for electrolyte, and we checked the specific gravity, and we know that this battery is good to go. We know that around the terminals there's no green, there's no heavy corrosion on it, so this battery is good to go. Let me see here. Okay, so another way we can check, if you don't have this meter, another easy way to check is with a true multimeter. Okay, you can, same thing, you can pick this up at Canadian Tire, any automotive parts place. So you want to set your meter to volts DC. This indication here is DC. And then what you want to do is I'll just prop this here up in the battery. And it doesn't really matter, it's not voltage specific. You could just go ahead and touch one terminal per lead, and I'll show you the battery condition right here. 12.73. So there you go, there's a fully charged battery ready to go for the summertime. Now if you do check the battery and all 6 cells are low, that may just be an indication that the battery may just need to be charged. So you can go ahead and charge that battery for the proper duration of the time and then recheck it. ABYC recommends that checking the battery 8 to 12 hours after you've charged it. Another way to test a battery is through a load tester. Okay, so this is just a carbon pile, a standard carbon pile load tester that can be picking up at your Canadian Tire or same thing, a Jobber, anywhere. So what that does is this actually puts a load into the battery. As opposed to just checking the voltage, it'll actually put a load. So
What's
a nice
a load?
easy way to do it. Sorry?
What's a load?
A load is something that causes the battery to work. So say a battery is at 12.73 like we see in here. If I were to hook up this battery here after a couple lights, when that incandescent light or LED light turns on, that's considered a load because there's electricity passing through an element or resistance. So that's what's considered a load. So what this does, this puts in a heavier load, like say for instance about 100 amp load, okay? And if you want to zoom in here, I've connected this to negative and positive. Now it's important to, it's polarity sensitive. So you want to hook the black here to your negative and the white to your positive. And as you see here, as soon as I connected it, the needle swept all the way to almost 13 volts. Okay. Now it says here 10 seconds to hold this switch. So it's a momentary switch. And what I'm going to do when I push it, this needle is going to drop down because it's putting 100 amps of current, okay, in this, through this battery. So the battery is going to work a little bit, but it's going to show you what kind of condition it's in. So if I hold this for 10 seconds, now you see the needle swept just over 11 volts and it's showing about 1,000 cranking amps. Now I'm just counting 8, 9, 10. So as I let it go, okay, the battery's recovered nicely. Now it didn't drop down the weak, okay, or anything lower. So I know that this battery's checked out the positive, or the voltage is good and it's load tested good. Okay. Checking it with your multimeter, load testing. Let's see here. There's another kind of testing that I have. It's called a conductance tester. Now, what a conductance tester does is same thing. It's polarity sensitive. It'll attach to your battery, and what it does, it passes checks the voltage drop through the cells. Some say it's more accurate, some say it's not. But there's I'm just letting it out, putting it out there. There's a wide variety of different testing equipment for your batteries. Now, I have quite a bit of inquiries come from Greg. What's the difference between a deep cell and a cranking battery? So a cranking battery, they're both the same thing, okay? They're both the same casing inside the hardware. On a cranking battery, the cells are a lot thinner. Not the cells, sorry, the plates. A lot thinner, but there's more of them and they're more closer together. And what that does on a cranking battery is that it delivers a strong amount of current but a short duration. So it's good for starting, because when the starter demands all that draw and that current, the starting battery can provide it. Now the other type of battery, a deep cycle battery. A deep cycle battery, but the plate's a little bit thicker than the starting or cranking battery. So in turn, what it means is that it delivers a moderate amount of current for a longer time, and it recovers easier. So if you were to take a cranking battery and a starting battery, and you both put a constant load on it, the deep cycle battery here would last a little bit longer. Now this one takes a little bit longer to charge than other performance. Now when you step up to these batteries, these are designed to be discharged and charged and abused. Because here is a 6 volt right here. So it only has 3 cells. So you want 2.1 volts per cell. So these plates are way thicker and a lot longer, as you can see the height of the battery compared to a regular automotive battery. So the capacity here is a lot stronger than an average size battery. However, it is a lot heavier, and you need to find a location to house these. And since these are 6 volts, these need to be connected in series together in a pair. So what does series mean? Series mean if I were to have 2 of these, 6 plus 6 is 12. So to make this connection, I would have to take the positive here and connect it to the negative of battery number 2. And then I would be left with these 2 terminals. And these 2 terminals, if I had my multimeter, would equal up to 12 volts. So that's how you get 12 volts in a 6 volt batteries. One battery that's kind of starting to make its way in the marine industry are AGM batteries. And AGM batteries, think of it as somewhat of a lead acid battery, but it's a very thick consistence. The sulfuric acid is almost like a gel paste, almost like a Vaseline. And it has a diaper-like material inside the cells. So that material is absorbed in those diapers. So that's why you can mount an AGM battery on its side or somewhere where it is very low ventilation. Now AGM batteries are built heavier duty. A 12 volt AGM battery equivalent to 2 6 volt batteries for harshness and durability. Another question that came up Facebook is that do we connect or disconnect the battery with a positive or negative first? Now this stems from the automotive industry. Typically you want to connect or disconnect your battery through the negative side. 2 things. If there's any chassis grounds or whatever, as soon as you disconnect from the negative terminal, you break that circuit, so nothing's open. Now if I had a wrench here and I would decide to disconnect from the positive side, I would take my wrench and loosen off the terminal, and if by mistake I hit that negative side as I'm disconnecting the positive terminal, I could cause a dead short and an arc, and that could damage myself or damage the battery. So that's why you always want to disconnect and reconnect from the negative. So you disconnect the negative first, and then your positive, and when you go to reconnect your circuit, connect the positive first and then the negative. And also don't forget when you're connecting your batteries back on the boat, you want to make sure that all the terminals are blown back on. You don't want to leave a straggler behind. Now the ABYC standard is 4 terminals per battery post. Okay, so post this way, or a nut, a lock nut, and a washer. Now they also state that you always want to start with your largest connection first, whether it's a 2 gauge, a 1/0, and then so on. So as you go on with the ring terminals, if I'm using this threaded post here, I go the largest connection first, but don't forget, 4 terminals per post.
Just have a quick question. What is this ABYC you keep talking about?
ABYC is to set the standard. The standard for safety, different regulations. They have regulations and safety practices for inverters, batteries, circuit protection, circuit termination, air conditioning, and different systems on the boat. because the marine industry is not very regulated. There's no by the government. So the ABYC is an American council that is trying to set a certain standard across the whole marine board.
Ross, thanks for watching, Ross.
I think that's it, unless there's any other questions. Once again, my name is Patrick. I've learned something anyways, and I wish you well, hopefully the springtime as well, and happy boating.
We'll continue to take questions after the video. Feel free to ask us questions at any time. Have a great day.